I can identify, if there's a question that you guys are struggling with, then we can discuss it a bit more in depth. But most of the simple questions, I will just go over them without discussing them too much. But again, if there are any questions, so we'll do 10 questions by 10 questions. And if there are any questions that you need to be discussed, that you found difficult, or that you had an issue with, just drop the message in the chat with that question number. And also, when I'm discussing, sometimes if I like say something wrong, or if I give a wrong answer, just feel free to just ask me, or just tell what you think, and so that we can make it more interactive, and we can reduce any mistakes that happen. So yeah, that's basically it. Feel free to send any message. So we'll start off with the first 10 questions. So these are my the first 10 questions for me. And if any of you all had any issues with these questions, I would have tried this. So did anyone have any issues here? Just drop a message in the chat. What did you all get for the first question? Anyone? Okay, so the first answer is 32. So one thing you have to remember is that when the division function gives you a float, so that's where you may make an error. So this absolute will give you the magnitude of any number. So here, since we have a complex number, the absolute value is 5. So, and here the 6 divided by 3 gives us 2.0, and that raised to the power 5 will be 32. So that is the answer for the first one. Yeah. So it's 32. And so this question, question number 2. Did anyone get any answers? Can you all drop your answers in the chat? Anyone? Yeah. So if you all did, I'm pretty sure a few of you all may have done this paper before. So if you all have, just drop a message in the chat so we can just discuss. Don't be shy to discuss. So to drop a message. So yeah, for question number 2, anyone got any answer? Okay, cool. So let's just okay, we've got one answer, which is C. Okay, interesting. Any other answers? Okay. Right. So yeah, this is a bit of a tricky question. I think this is a question that I also got wrong at the exams. So first we'll discuss what happens in these lines of code. So initially, this line, you will set everything to 9, and you will assign those values into this list, which is named L, right? So one thing you have to note is when you assign numbers like this, right? You don't assign a reference to the object A. What you do is you add a copy of A in L. So A, B, and C are not references to these 3. It's just a copy of the values, which will be 9. So when you set B to 8, it will not change the B inside this list. It will just change the B here. So it will just be 9 here. So it will be 2, 4, 5, 9, 9, 9. And so when you're deleting also, the same thing applies. So it will just be, so B and C will be deleted, but it won't have any effect here. But deleting this L3 will delete the 4th term, which is this. So it will be 2, 4, 5, 9, 9. And the answer is A. So that is the correct answer. Well done. So yeah, I think one thing to be aware during the exam is not to make any silly mistakes, and I think I've done this during my exam. So the answer is not E. It is actually uh, the answer is A, right? So then the next question, we have considered the following statements. The operations can be. So what did you all get for this question number 3? What were your answers? So the correct answer I got is E, which is none of the above, mainly because so operations can be performed depend on the value of the object. That is wrong. The operations that can be performed on an object depend on the type of the object. So that is something you should be aware of. So for string there are certain operations, for integers there are certain operations, uh, and so on and so forth. So depending on the type, the operations will change. The identity of the object will change when it's given a name. And that's also not true. The identity is where it's saved in memory. So just because you change the name, that will not change. And finally, the value of a string object can be changed by assigning a new string. That is also wrong. Just because you assign a new string, you may know that strings are immutable. So assigning a new string, you will be creating a new string object. So you will not be changing the value of the string object. You will be creating a new string object. So the answer is E, which is none of the above. So the next line is consider the following 4 lines of Python code. Which are the following is correct about the code above. So you can see in the first line, we are trying to access the second, which is this list. And in that list, we are trying to access uh, the first index, which is this. And in that, we are trying to access the 0th index, which is 8. And we're setting that to 4. So that's allowed. So that's not an issue. That's correct. The second one, what we are trying to do is we are accessing this. No, sorry. We are accessing this. So we are saying W1 is a list with 2 times the value of W1. So it will be 2 times 2.5. So 2.5s in that list. And we're also adding bar to that list. So that also doesn't have an issue. No problem. Here, what we're trying to do is we are trying to access this and its first index. So you know numbers don't have an index. So that is wrong. So the answer uh, will be uh, which of consider the following. Yeah. So the incorrect statement would be 3. I think I'm missing a part here. Yeah, so I think they're asking us for the incorrect statement. So the incorrect statement here is line 3. So I think that is all right. Then similar question, which similar code. So he also here they are trying to access this list, and then in that the second element foo, and here there's an issue. So we are trying to set. We are trying to so we are accessing foo's first character, and we are trying to set it to B. So you know that is wrong because you can't uh, change strings like that, just like you change list. So that is wrong. Then again, here we are trying to add ABC to this value. So that again is wrong. So I think there's another mistake there. So this is also wrong. And finally, we are trying to access this. We are trying to access 2, and we're so 2, and we're trying to multiply it by 2. So we're trying to make it foo foo. So that is not an issue. So that is correct. So the error is not in only 1. It's actually in 1 and 2. So I hope that is clear. Next, we have another similar question. We are trying to access things in. We are trying to not actually access. We are trying to check if something is in a list. So just have a look here. So x is 8 and y is true. And just be careful because this is not the Boolean true. It is a string which is true. So there's a difference there. So first we're trying to check in W2, which is this list, do we have 8? So you can see at first glance, you may think there's an 8, but this is actually not 8, the integer 8. This is actually a list with which has the integer 8 inside it. So that will return false just because there is no list element which is the integer 8. There's a list element with which is another list. It's a nested list, but that will not uh, give true for this question. Similarly, when we try y in this list, you can see the boolean true is there, but we don't have this. What we are checking for is the string true. So again, that will give false. So since it's an or, it will be false. And also just be careful because these are like just trick questions. When you have like an or in a statement, it will give the boolean what do you call to give the boolean solved value of it, like it won't combine it or do anything as such as in answer C and D. So question number 7, we have a bit of a we have Python expression, so which is using the binary representation. So I think you all have to learn a bit about how these work. So in octal, so here they've given us 210 in octal. So when you convert that into binary, it will be something like this. So then the next part is right shift, which is which this says you're right shifting this number by 3 digits because this is binary 3. So when you right shift this, what you're doing is basically taking this 3 digits. So 1 0 0 0 1 0 0 0. So remember, you fill the when you right shift, you fill the remaining bits with 0. Then here they are saying not 8, so 8 looks like this. Uh, so not 8 would be something like, sorry, like this. And there's an AND operation with XDA. So yeah, that is in hexadecimal, as you may know. And XDA in binary is something like, yeah, this. I'm not sure if you all will be allowed to take your calculators for this exam. I can't really remember, but I would recommend to try to learn converting binary to octal as like doing it like learning to convert them fast, because that is the main issue that you would have. So and then this is or, like you have an or operation, so which would give you 1 0 0 1, and yeah, so I think this will eventually give you 211, which is the correct answer. So I hope that was clear to you guys. I'll just leave this here for now. So that's how you do it. So this is, I think, the main point of confusion might be this. So this is a right shift, and other than that, very simple stuff. So next we have this question: what is the output of the following code if the input is this? So as you may know, we are splitting this string with this, and we are appending u, then we are sorting it. So you just have to check how it will look when it is sorted, and you know that when you run sort, it will just sort it in alphabetical order. So one thing to remember is, so if you do something like p dot sort, it will change the order of p. That's not an issue. But if you're using something like, there's another function called the sorted function. So if you're putting p into the sorted function, you should remember to assign it to p afterwards, because sorted returns the sorted a copy of the sorted elements, but dot sort will do the sorting in the list or whatever that you ask it to do. So just keep that in mind. That might be a trick question that they could ask. Next, we have this question. So 9, they've given us a reading a file, and so what is correct? So the code does not have any syntax errors. That is correct. As a good programming practice, code must be added to close the file. Yes, that is true. As a good programming language, they ask us to close the file. But something that we have to understand is when you write this code like this with open as in file, it automatically closes the file after you're done with it. So because of that, for this code specifically, you don't have to add a separate code to close the file. It will be closed by itself, so that's not an issue. So because of that, for this statement only, it is wrong, because close is already included in this internally, but otherwise it would be correct. And an exception could occur at runtime. Yes, there could be exceptions such as the file not being there, or file not being readable. So if you don't have read access, then you can't open the file. Or if the file, if my file.txt is not there, it still will give an error. So the answer is 1 and 3. So next question is this. So here the main issue is if you input 5, it converts it into an integer, and you have a match case statements. The question you would have is what would happen if, so now they've given us 5. So you can see that 5 would satisfy this case, and this case. So you may have problem like, would it go to this straight away, or would it go to this and this? So the answer is actually it will go to one of the cases, and the first one that it finds, which is 3 or 5, and it will print 3 there. So that's the answer for this question. So the first 10 questions are done. If you all had any issues with it, just you all can drop a message in the chat. Was there anything that you all where your answers differed from my answers? Okay. If not, we'll move to the next 10 questions. So if you all had any issues in these 10 questions, just drop the question number in the chat. Yeah, these are the next 10 questions. Okay, so that's one question. What does the case keyword mean in Python? So this match case is a simpler way of like, it's not exactly a similar way, but it's another way. Like, it works like if statement. So for example, for this code, if you're going to write like like how they've written, you would have to write something like if num equals 1, else if num, I mean, there are no brackets, I think. Else if num equals 2, else if num equals 3 or 5, or num equals, so it would be, it would actually have to be something like, or num equals 5. So you can see that the code will look a bit cluttered, and there'll be a lot of things to write unnecessarily. So these match case type statements allow us to make the code look more cleaner. So what this would do is, you would like, it will match the number here, which the value of this num, with these cases. So if your num is this, it will do this. With this, it will do this. So similarly, it will go on, and I believe this is the default. This is the default case. So that means if it's none of these, if none of these are done, this will happen. So that's how match case works. Yeah, so if someone has asked if input is 10, what will be printed? Yes, that is correct. It will be what? Because as I mentioned, this case underscore is the default case. So if none of these other cases work, this is what will happen. Yeah, so good that someone answered. That's great. So yeah, if you all have any questions like that, keep ask, and I hope this answered your question. Okay, all good. Let's move on to the next question. So here, this is basic Python code. So they've asked how many exceptions will occur in this code. So can you all put the answer? How many exceptions did you all get? What was the answers that you all got? How many different types of exceptions does this give? Three. Yes. So yeah, the correct answer is three. So if I ask what are the uh, uh, this one, so you just look at it line by line. So here you obviously can get a type error where you can't where you input something that you can't convert into integers. And knowing our people, when you say input an integer, some people will put a string just to try out what will happen. So obviously there's a type error here. I believe, yeah, that's what it's called, type error. And then here, if so integer, then let's go to this line. When we come here, you can see there's a division. So when there's a division, you should check if this value can be zero. So you know that you can take this input as zero, and there will be a zero division error here. And finally, there's an issue. I think this is what there's another problem. So what if someone inputs a number that is greater than 5,000? So then p will not be defined. So uh, yeah, I think it's value error. Yeah, that's a so that's a value error. I'm also not 100% sure, but I think, yeah, you're correct. It's a value error. And finally, so here you'll get p will not be defined. And what's the name of the error in that? Mm, yeah, it will be a name error, if I'm not mistaken. Yeah, the final error will be a name error, because if this code is not executed, then p will not be defined. So that is that. So question number 12, the answer that I got was 80. uh, so if anyone so these questions, it's just logic. I mean, you have to uh, go through this, these loops, and check how what gets added, how your values change, and get the final answer. So the answer I got here was 80. If you all got a different answer than this, just let me know. I won't go into this in huge detail. It's just you just have to follow the code, right? Question now, if but just again I'm repeating, if there were any differences, just drop a message, right? So question number 13, the answer is 3. So again, I think that's also a pretty easy question. uh, it's just, if the number is divisible by 3, you print that number. So from 1 to less than 6, which is 1 to 5, you will only print 3. So that is also all right, I believe. And the next is, what is the output of this code? So again, this is about the range function. So you know that you can define range in many ways. So if you give range like this, uh, you will get the numbers from 0 to 10. If you give so that is what you're saying, is you're just giving range with the end number. So you can also give range with two uh, values, so which is basically uh, the start and the end value. So this will also give the same thing. So let's think we change this something like 2. So then we would get the numbers from 2, 3 and to 10. And finally, we can give the range like this with 3 arguments, mm, which would, the final argument is actually the step argument, which would say, give me the numbers from 2 till 10, but every other number. So you skip 2 values. So in the sense, so 2, the next value will be 4, and then 6. So it will give the numbers until 10. So here you just have to iterate on what numbers you would get. So you'd get 1, 2, 5, 7, and 9. So remember, this number is not included. So when you sum them up, you will get 25. Okay. So I think that is okay for that question. Just give me 1 minute. Okay. So the next question, again, this is a uh, simple question. You just have to figure out how the for loop works. So we are iterating. Sorry, we are iterating these values. So you'll iterate here 4 times. You'll iterate here 4 times. So you'll print this 16 times. So that's again a simple question. If you all have any problems, just drop me a message. Question number 16. The most accurate statement regarding the following Python code. The program will enter an infinite loop as number starts at 1, is incremented by 1 at each iteration. So I think this is the correct answer here. Uh, so it doesn't actually increase an infinite loop because total starts at 1. Because in this while loop, we are checking this number variable. So while number is greater than 0. So if number goes below 0, only will come out of this while loop. But you can see that at no point will number go below 0 here. So because of that, the correct answer is A. Next, we move to this. Again, very simple question, but there's a small trick here, which I believe we may miss. So, in a for loop, I think what concerns is this else statement. So, in a for loop, this else statement will be executed if the for loop is exited naturally. So basically, like if you iterate over all of the values in this and you're done with it, then this else will be executed. But if you forcefully exit the for loop, then this else statement won't be executed. So that is something that we may miss. So because of that, you can see like you iterate this, print the value, and if value is 3, you break. So you can see in this range 5, value will be 3 at one point, and then you will break. So because of that, done will not be printed. So that's the answer for that. Next, how many asterisk signs will the following code print? So you can see again, this will break at 5. So from 0 to 5, which is these 4 numbers, it will iterate. And if value is 3, you will not go to this part because you have continued. So you will just jump to the next part of the loop. So that is also something to remember. So so these numbers actually 1, 2, 3, 4, 5. But for 3, you will not print this. So the answer here is 4. For these 4 numbers will be what you print. Question number 19. I think you just have to remember what this index does. So index will give you the index of the first found element. So if you check in this, you can see for James, the first element, the index will be 1. You can see there's a second James as well. But as I mentioned, this index function gives you the first index of the first found value from when you start from index 0. So there are more functions like this. I remember there was like something like search from right or search from left. There were certain functions. But I mean, if you all have time, if you all have a bit of extra time, go to I think W3 schools or Geek for Geeks. One of the two had a good uh, had a good they had just listed all the uh, methods. I think it's W3 schools. Yeah. So like this. So if you all have sometimes go on W3 schools, this is how it looks. So you can easily like see what are the different yeah, it looks something like this. So on the W3 schools website, this is the dictionary. Just zoom in for you for a bit. So these are the different list methods. So similarly, they have for like all different other data types. So if you have some time, just go through them. Like you don't have to go through them in depth, but just go through like a few common ones, because just in case they give something like that. So the next question, we have a list concatenation, and what they're doing is they're joining the two lists and sorting it. And as I mentioned, how sort works, so you may remember that. So they sort this list, and then after that they print uh, the uh, so they slice this list. So this tells us to print the scores from 0 to 1. So it's not including 2, so it's from 0 to 1, so the first and second elements. So you can see when you sort this, the first and second elements will be 32 and 54. So the answer will be C. So next we have this question, which is the find function. So find works something like index, where it will find in a so in this string, it will find the first occurrence of in, right? So when you read this sentence, you might first think that this in is what we would find, because when you read it, this is in. But the computer does not, the Python code will not find out what in, like it won't find the grammatical in, right? It will actually just find the first occurrence of the two characters in, because that is how computers think, right? And you may also have noticed, like even with ChatGPT, it still cannot answer very basic questions like this. For example, if you ask ChatGPT to give the number of R's in strawberry, it will like struggle like crazy just to find the number of R's in strawberry. But I think maybe that was a fix recently, because everyone keeps asking that question. So because of that, that's just an example related to this. But here you have to just find this the occurrence of this string. So here is where the first in occurs, not here. So it will give you the related index of the first value. So it will give you the index of this 1 2 3. If you keep counting, this will be 16. So the answer here is 16. So this question again, we are we are concatenating two strings together. So you may, all those strings are immutable, you can join them together and uh, assign them to a new value. So that's what we've done here. And here what we're doing is we are slicing it from 0 to the uh, fifth element from the end. So it will be something like 1 2 3 4 5. So you will slice it from here. So the answer will be 6 to 4. So here this is also a similar question where you would iterate on the characters in this string, and for different values you would do different things. So you can see you break from this n, so nothing is printed, nothing is added to output string here, but everywhere else you would add these two the output character except the e's. So you will add x c l l, so that will be the final value. Next we have another find. But yeah, what you're doing is you're finding something. So you get the index of this, and you get the index of a space. So you can see that this find has been here. The find has just been given the string that you're finding for, but here they've given two arguments, which is, and the second argument is from the starting position. So this find also has, I think, three arguments. You can give it the search string, the starting position, and the ending position. So when you give it the starting position, it will start searching for the space. So here you given a space, no? So it will search for a space from here onwards. So the first space is here. So that will be the index of your SP pos. So, and then after that, what you're doing is you're slicing that again. So you're going to from here to here, which will give you abc.com. So the next code is like a bit of a string manipulation, a string, I think it's called a formatted string, if I'm not mistaken. So these two will tell you to, uh, so this is this, what do you call this, percentage sign will tell you this is a string to be formatted. The 5 here, so first we'll talk about this. So this 2f tells us that you should give the floating points should be rounded off to 2. So you can see my answer here has selected this. So it will round off to 2 decimals, and this 5 here gives you the minimum number of integers. So this 5 is doesn't tell you that the numbers, the digits in front of the floating point should be 5, but it gives you the minimum number of integers included in this string. So here you can see already even the parts in front of the decimal have more than 5 numbers. So because of that, it won't be an issue. So the answer will be D. So question number 6, again, a simple question. The answer will be A. You're iterating backwards from 4 and printing the integer that many times. So the answer is A. Then here again, this is a bit interesting. Now we've come to functions, right? And so we have a list called numbers, and we call this modify list items. We call this the modify list function actually, and we pass in numbers. And inside this, we append 4 to this, and so we are doing a bit of a few changes. So one thing to realize is that here, so this will reference these items, right? The items that was passed in by reference. So it will so numbers was passed in by reference. So when you're appending something, it will append to this object. But if you are defining items again, then this items is within the scope of this function. So there's a bit of a difference between those two. So this items is within the scope of this function. So just because you change it, so it's a local variable. Uh, so uh, yeah, so this is a local variable here. So because of that, it will just append 4, and this change will not make a difference. So what you'll get is C. Yeah. So yeah, that's a good question. Is it a minimum number of integers or characters? So yeah, I think it is, if I'm not mistaken, characters. Yeah, I will check that and I will let you know at the end of the session. I think you may be correct. Characters might be the answer. But let me see. Yeah, I'll check that and just let you know about that. Uh, yeah, but you may be correct. So yeah, and question number 27 is also fine. Question 28. So here again we have a different function which is modify string. So we define hello and we pass it in to modify string. So you should remember that integer strings, those are not passed in as reference. On usually lists are passed in as reference, but objects like integers, strings are not passing as reference. So here, whatever you do to hello inside this function will not have any effect on this uh, variable text. But if you were to return s here, like have something like return s, and you save this modify string text equals modify string, then you would probably get something like hello universe. But in this case, we don't have that, so it will just be hello with no changes. Next question: what would be the output of the following uh, Python code? So we are calling greet here, and it looks like you will print hello plus the name. But it looks like the code looks okay. There seems to be no issues, but there's a small issue when we call the function. So here, this is we've defined the function to take one argument. So since this is not what do you call it? It's not an optional argument. We can't call the function like this. We definitely have to pass in the argument. So because of that, this will give you an error message. It won't print anything, right? So the next question, we will take in this string. So here, it's pretty much the similar format. It's just we've passed in the uh, arguments by naming them. So sometimes you can just, if you just pass it, put the values, it will be assigned by order. So whatever you put first will be name, whatever you put second will be age. But here, since they want to give it in a different order, they have named this and submitted it, so that won't be an issue. So it will come as name John is 25 years old. So the answer for that is A. So question number uh, 27. Yeah. So I also tried this. So that was something I also was confused about. So what I found out was uh, when you define items like that inside the function, you will that items will be a local variable. So let me try running that again once again. So because of that, what I got was the answer you get is 1, 2, 3, and 4. But yeah, let me just run that again just to show you. So when you run that, you just try running that code in some in like maybe a notebook or something. That is the answer you get. So what actually happens is these items, these local variable items, will be assigned to this list. So then you lose access to the list that you have. So I think if you try adding another value. So what has happened here is, so when you call this function, these items is local inside this function. So at the beginning, these are items, this local variable items has the reference to what has been passed in this numbers list, right? So then you append for, it will append to the reference list. But here, what you're doing is you're assigning a new list to this local variable that we already have. So then the reference that we have assigned to items will be erased, and instead items will be this value. So because it's an assignment, so you're assigning something else to our local variable. So because of that, you lose your reference to this the argument that we passed. So if you were to do something like this, items append 5, right? It would still it would still return the print value will be 1234 because we have lost access to the reference, this numbers reference. So because that's mainly because you assign something else to items. So you can't do assignments, you can do additions, you can uh, I think you can append, you can pop, you can do those things, but if you assign you will lose access to uh, that reference. So I hope that's clear. If you still have a doubt, just let me know. So wait, you tried put in the function inside print that gave. Can you just send me the syntax of like whatever code you wrote? I put in the function inside the print. I don't get what you meant by that, but uh, modify. Okay, so Dulana, the answer to your question is because you're returning items. So here in the code that we have here, like question number 27, there is no return. So if you what you did without that return items, then you will still get the same answer. So yeah, so I think Lakindu has got like a similar uh, you got a similar answer because yeah, because after altering the list items the function doesn't return the list. So yeah, that is partly the answer. So but in the sense, for objects like lists you don't have to return it for changes to be made, because as I mentioned, lists are passed in as a reference. So it's not like you're passing a copy, you're passing something like, you can think of it as the address of this number. So when you pass in this numbers list, you pass in something like the address. So whatever changes you make here will be done here. When you assign another list to these items, then you like something like you're redefining what this items is. So then that uh, the reference that was saved, so the reference to this numbers list that was saved in items will be removed. So that is the problem. So yeah, so without return the answer will be none, because what you're doing is uh, uh, your function returns nothing. So because of that's the difference. So in the current function that we have here, this function returns nothing. So even if you if you want to print something, like the function has to return something if you are just putting the function as you did, right? So I think that's the issue that you had. But for this, just remember it like this. So when you define it like this, you lose the reference to the object that was passed in, right? And the easiest thing to do, I would say, is instead of like passing in by reference, is would be to just return it and save it and then do whatever you want to do. So that will make it much more easier. So yeah. I hope that is clear. If you all had any questions, if you all still have any questions on that, just ask me. So yeah, that's a bit of a tough question, I would say. Okay, so next we'll move on to 31. So these are easy. So the answer for this was 15. The answer for this was 0. Again, mainly because what I mentioned before, you don't, just because you call the function, you don't change the total here. You're not changing the total here. What you're changing is the total inside this function, which is local to the function. So I'll ask you guys one question. What if we pass in total like this? We take in a argument like this and total. So what do you think the answer would be here? Just drop a message. Try. What do you think the answer would be if we run this code, which I've just edited here? Anyone got the answer? Mm, no one? Okay, so what would happen here is, as I mentioned, it would be the same thing. It would still be 0. The reason is that when you pass in integers or strings, they are not passed in by reference. You just pass in the value, right? So there's a difference between how integers strings are passed in and how lists are passed in. So because of that, even though you pass in total, uh, you'll still be doing the same thing. So what you would ideally to see a result here, the best thing to do would be to, since you're actually returning here as well, so you're returning the value total equals this, or you can do what Dulana did and just say uh, print print add. Yeah, you can just put the print here. If you print this, you will get 15, right? So I think that is also all right. Then question number 33, how your um, how these numbers are shown. So this is, I think, the answer would be C, where the most significant bit, which is the leftmost side. So this is wrong. LSB has the highest value in the binary number. That is also wrong. That is the one before the MSB. LSB and MSB cannot be one. That is also wrong. So they can. LSB is always 0. That is also wrong. So the correct answer is C. So, and then question number 34, the correct binary representation of this would be, so you can see that it is like made of 0 0.25, 0 0.125. So that is 0 0.375. I think actually the correct way to do this would be multiply this by 2, then you would get something like 0 0.750. So then 0. And then you would get you'd multiply this by 2 again, then you would get 1.50, which is 1. You multiply, then you would multiply the part after the decimal, which would give you again 100, which is 1. So the answer would be uh, 0 uh, 0 1 1. So I think that's the answer here. So yeah, 0.011. Next is question number 35, division. So I think that's also, you can just do this simply. So the answer is C. And correct 8-bit 2's complement of minus 27. So I think you know how to represent this. So first you write 27 in 2's complement, which would be 16, 8, 24, then 0. This I think this is the correct representation of 27. Yeah, so this is how you represent in 27 in binary. So 8-bit number is like this. So then you know to convert it into 2's complement, you flip the bits 0 1 0 0 and add 1, which is 1 0 0 1 1 0 0 1 0 1. So it should give you a. So that's the correct answer. Next, I think we can see how these functions work. So you may have encountered them when doing your PP1 or PP2. So CHR converts an integer to its Unicode character. Odd gives you the Unicode character from the integer. Like gives the Unicode. Gives the Unicode gives the integer of the Unicode character. So basically, it will tell you the Unicode value, right? So if you give it a character like maybe a, like something like odd a, it would give you, I think, a value some 60 odd value, yeah, and capital A is some 90 odd value if I'm not mistaken, or maybe it's flipped. So there are specific Unicode values for certain characters, so you will get that from odd. So if you give this value, so if you say something like CHR63, it will give you whatever value you converted it from. So I think this would be, if I'm not mistaken, uh, simple A or capital A. I can't remember the exact value, but it's something around this. And str, it converts a specified value into string representation. So that is, so I think it can convert the, I also haven't used str, but I think it can convert anything, like maybe even a integer, it can convert into a string. It's something like int, it's like the int function. So that's what that is. And so you can see this, what you basically do is get the Unicode value of Q, and you should know these Unicode values are sequential. So -1 + 1 will just reduce it by 1 or increase it by 1. So when you get odd Q and reduce it by 1, you would get the Unicode value of character P, because P is before Q. And so the answer would be, and when you to get the character P, you have to convert it using the CHR function. So that is that. Then next we have this question where you have to first you have to convert this into uh, uh, how do you call it, into binary. So we'll just do that 0.03150. So that would give you a 0.6250, so 0, then 1.250, which is the 1, then 5, 0, because we only multiply by the side on the other side of the decimal. So on the left right side of the decimals, that's the one we multiply by 2, right? So here again 0, so it's 0, and when you multiply this again, you get 1.0, which will be 1. So since this is 1, do that until we get 0 on this side. So value will be 0.000101. So then now we have to convert this into like, I remember that scientific notation. So this would be like this, no? So 1.01 into 2 to the power minus 3. Yeah. So since this is in binary, so then after that they're asking, so there are a few things that they're asking us. So first the sign bit. So sign bit is 0 for positive numbers, sign bit is 1 for negative numbers. So here we know sign bit will be 0. Next we have the exponent. So you all should actually study this, how single precision format is given. So in that, what they've said is you have to add your exponent to 127. So that is because so our exponent has 8 digits, so you can show 255 unique numbers. So they have divided into positive and negative. So since you don't, it will be a pain to keep checking like two's complement. What they've said is numbers higher than 125 are positive, numbers lower than 125 are negative exponents. So what we do is we add that here, so we get 124. So this value is actually 124, so that is our exponent, and the mantissa is just basically what is after our decimal when we convert it into that scientific format. So it's 0.01. So I think the answer was A. So if you all have any questions, just let me know. But I think better if you all also research this, because it has been quite a while since I also did a sum like this. So just go through your notes, and I think that's explained, or even internet has some good videos on that. So next question is this, which is question number 39. Again, pretty basic question. And uh, to get the output, so basically they want us to swap. I think, yeah, they want us to swap the numbers. So what we should do is we give the list and the indexes, and it will just swap it for us. So we give the start and the end, and it will keep swapping like going inward. So for example, if you have a list like this, it will first swap these two, then you have to give it these two indices to swap these two like this. So what will the correct answer for that is you keep increasing the point on the left and you reduce the point on the right, so that is this. So next, what we have is uh, Mm, this is actually called a palindrome. So they want us to write this function to check for a palindrome. So a palindrome is a number, a word that can be read the same way forwards and backwards. So here you can see it just checks if it's, you have to check if the, uh, what do you call, if every like corresponding from the left and from the right, if every corresponding two characters are the same. So what you do is you first give in the list and you check if the first and the last are the same. If they are not the same, you return false. But if they are the same, then you have to check what is inside. So for that, what we would do is we would send in, we would call this function recursively, giving the inputs as the one, like not the first digit, the next digits, and from the end, also the one before the last digit. So you give, so instead of, let's think, the first thing was race car. So it will check the two R's. Once you got that, you pass into the function is, so you pass in this, so then it will check these two, then you pass in CEC. So you can see the answer that we get is D. So that's the answer for this question. So we are halfway through, so if you all have any questions that you all would want clarified, just let me know. So let's move on. So from 41 to 50, if you all had any questions, drop a message. So this is actually, I think, the sort questions. I know this is the ADT question. So like the stack and pointers, and then after that we go to the sort. Yeah. So let me know if you all had any issues with those. So when we go to question number 41, we again have so why what they're asking is for for the output to be 29, which the line Z should contain which of the following. So for output to be 29. So think what they're asking for is the biggest. Yeah. So I think they're asking us to find the maximum. So what we should do is we should iterate over all of this, and according to this, if a number is bigger, we assign that number to X. So we are saving the biggest number. So because of that, we should just iterate over everything. So for y in L, because L is what is passed in as the argument. Next, we have another question for output 0 to be 0q. Yeah, what which should it contain? So you can see there's a I and a X here. So there's no I anywhere else. So you can see that our for loop, when we are defining it, we should uh, define both I and X. And then we should find a function that will give us not one, but two outputs. So from this, obviously, range is no, these two will be no. And even for L, we can't get two values because you can see this is a list. So when iterating, you will only get uh, one character. That's also wrong. So by eliminating things, you can get this answer, which is enumerate A. But a simple thing to understand, when you call enumerate A with iterable item, something like list, or even maybe I think you can call it with string as well, or something like that. What you will get is each item, each element. So for example, this you will get pairs of uh, it's like combining range and a for loop. So you will get like this, you get something like 0q, uh, 1w, uh, 2e. So that's what enumerate does. Enumerate gives you it iterates through a iterable object, and it gives you a tuple with the index and the each element. So that's what happens here. So I hope that is clear. So the answer is E. So next, let's move on to the ADT questions, which so here what they've said, they've given us is above code to create an empty list with size number of elements. The line Y should be which of the following. So you can see we are creating a self.buff, which is usually called a buffer, and we should create a, a list which is of a given size. So the size is passed in as an argument. We should create a list of that size, and there are many answers. So for example, something like this is wrong. These are wrong because if you don't usually use a new in Python like this. And this is also wrong because what you would do is you would get a list with one element which is none multiplied by size. So I think this might even give you an error. So that's also wrong. And this is also wrong. So the correct answer is this. So you know, with lists you can get with this specified number of elements by this operation. So yeah, that is that for this that question. So in the above code, the class ADT declared in line X is a data structure which has the behavior which are the following. So you can see when you're getting things out of this data structure, you get the uh, element defined by the pointer. So we'll figure out what this pointer does. So you can see when you're adding something, you add it to the pointed value and you increase the pointer by 1. So you can see it's something like this. So you're adding it, your pointer will go here. Then you add it, your pointer will go here. So then if you remove something, you remove it, your pointer will go back here. So you can see this is like a last in first out. So this is like a stack. So that will be the answer here. It's a last in first out. Is that clear to everyone? So next we have a first in first out data structure, which is what they're asking for, which is a queue, right? Uh, and so what they've asked is for the class ADT declared in line X to behave as a queue data structure, the line Y should be which of the following. So for a queue, basically the pointer will be in the first element, and you will be adding to the end, right? So that's how a queue would work. And you can see when you define, so you define a size, and so you define a size and you define a pointer. So you can see what we are doing is if pointer is greater than 0. So if again our pointer is showing the next addable element, so still doing that similar thing, like it shows you where you can add the next element, because you can see this pointer, you when you're putting, you put it to uh, uh, mm, yeah. So you can see here when you're putting a new element, you will put it to the value given by the pointer, and you increment the pointer like here by 1. So the pointer will show you your last element, so where you can add a new element. And so what so then our question is, what will happen when we are taking out elements? So from the queue you have this many elements. If you want to take out this element, what we would have to do is, we want to take this out, we have to move every element one step forward. So that's what we have to do in this get function. So for I in range self dot pointer, so from uh, so you iterate from 0 to the current pointer value, and we have to bring each element to the previous element. So what the correct answer here is this: self buffer I equals self buffer I plus 1, right? So I hope that is clear. And next we have uh, another uh, the code to add the elements. So what they're asking is for the class ADT to behave as a queue data structure, the line Z, which is the line which you add the element. So you should add it to the pointer, as I mentioned before. So buffer self dot pointer equals value. So take a bit of a time and analyze like whether it should be this +1 -1, because they can change it according from question to question. So with the code that's given, you should try to analyze and figure out whether it should be +1 or -1 or just self dot pointer. So, all right. So now I think we will be moving to the sorting questions. So, or is this a sorting question? Oh, no. So this is a search question. So you can see they've given us. Yeah, this looks like a search question. So what they've done is they're giving us the list, which is L. They're giving us the 0 index, which is I, and they're giving us the last index as J, and they're giving us a value to search. So yeah, so this is a search equation. So you can have an idea of like what it looks like. Based on what it looks like, you can get an idea of what the function is for. So here, what they're saying is if J is I greater than I, or I is greater than J, so that means so what we do in this is, so we give it like we give two pointers, and we keep shifting the pointers this way either side. So if the left pointer, which is this, has swapped with the right pointer at some point, we know, okay, we have searched the whole list, there is nothing left, then we can skip. So that is what that does here. And then what we should do is one thing that we have to remember. So you can see here, uh, for v, if v is equal to lk, so this is a binary search. So what we do is we check the middle element. So we are checking for v, which we is what we are looking for, is it the middle element. So if it's true, then you return true. Else, so then you should know what is k. So you have to figure out that k is this divided. But remember that uh, uh, k, if you do use this division, you will get a float, so that will give you like an index error. So you should use this here. And then next we will figure out like what we are going to pass in as like if v is less than k, then that means if like when you divide this into parts, so if v is less than this, then you have to search here. If v is greater, you have to search here. So that is what the code here is. So you will keep I as it is if v is less than k, but you will change k. So you will change k from this to this. You keep the I value here. So similar thing for the next thing. You will keep the I value as it. No, you will keep the k value. So the final value will be here. You have to just get I from here to here. So it will be k plus 1. So that is those are the two answers for that question. And next we have, uh, yeah, I think this question is the uh, this is actually the greatest common denominator. No, what is it? Greatest common denominator. No, greatest common factor. Yeah, the greatest common factor equation. So there are two equations which are the greatest common factor and the least common multiple. So this is what it looks like. So I would recommend, if you do have some time, to like try to understand that those two equations, because it's a bit like if they do ask you at the exam like something like this, it's a bit tough. Like it takes some time to manually plug in the values and try to get the answer. So because these are recursive, it takes some time. So because of that, so the correct answer was B. So just if you have some time, just go through those two equations, those two functions, which is the greatest common denominator and the least common multiple. These are very simple like concepts. Like these two are which we've probably been taught in like grade 6 or 7. But it's just the way we write the function is a bit different. So just go through that if you all have some time. Next we have a simple function, I think. So uh, so for the output to be 36, so I think 36 is basically by multiplying this and this and this and this. So what are the answers that we should get? So you can see that we will take from L, we will take the first element and the second element, and you can see 36. So it's actually not multiplying these two, you multiply the difference. So you multiply the difference between these two, which is 6, by the difference between these two, which is again 6. So 6 into 6 is 36. So you have to first take uh, the first list, the first tuple actually, and you should take the values as one as x1 and the other as y1. And the next you have to take the you have to extract the values in this as well similarly. So the answer would be this, which is C. So I hope that's clear. So yeah, so that's the answer for question 51. Next, let's move to this, which is the quick sort. So we have quick sort and merge sort, which are actually, in my opinion, which were for me the two toughest sort algorithms. So we got both of them during our exam. So, but again, if you understand the basics of how it happens, like how like the logic behind it. So I what I did to learn these two were, there were some YouTube videos which showed the visualization, like how uh, how it visualized how these divided it into parts and then sorted it. So I feel like that might be useful uh, to help you understand and get an intuition for these sort algorithms. So quick sort, what we do is we select a pivot, and based on that pivot, we divide it into few groups, which would be the lesser than, greater than, and the equal to. So you can see here we have the lesser than, greater than, and equal to, and then we have the sizes. So what we are doing here is we are sorting them based on the pivot. So I think line P is where we would select the pivot. So what they've asked is what cannot be used as line P to select the pivot. So you can see that here when we select the pivot, uh, pivot has to be an index. So if you give in size, you'll have an index error. So you have to give size -1, or you can see size divided by 2. All of these you can give, which are smaller than size. But if you give exactly size, it will give you an error. So that's the issue there. And next we have line Q. So which should you do here? So what we have to do is, so we keep dividing these into smaller values based on the pivot. So here, equal data. So now once you, let's say we divide it into uh, values based on the pivot. So these are sorted. You can understand these are less than the pivot, these are equal to the pivot, and these are greater than the pivot. So these three are in sorted order, but in the values inside this, these may not be sorted. So because of that, you have to sort them. Now the equal to, you don't have to sort because they are all the same value, but this and this you have to sort. So then this is what we would iteratively call. So because of that, we would call quick sort this, and quick sort greater than, and quick sort less than. So you can see they've given this as well, but it's not necessary, because since it's equal to, it won't make any difference. And finally, what we have is, now once we finish sorting, uh, we have to append them to the final list, which is data. So what we keep doing is, iteratively we will keep adding. So until um, else, so we have added the lesser data. So basically we've added up to lesser data. So you should understand, now we've added until L size. So the next value should be L size. It should start from L size. So it should be L size +1, because the first I will be 0. So it will start from L size. And the next one will be L size plus E size plus I. So those are the the three answers actually for quick sort. So I hope you guys understood. Mm. So next we move on to merge sort. So merge sort is so this is the code that we have. What they've asked is for merge sort to reach a trivially solvable problem status, line X should contain which of the following. So uh, what we would do is, like, we would keep merge sort if we have like lists like this. We would keep dividing them, like from here we would divide, here we would divide, then again we would divide, like from here, divide from here. And final, like a trivially solvable size would be, I think, I believe when size is 1. So I think when start and end uh, is less than 2. So it's basically, what it's basically saying is, when the size is 1, then we have come to the end of our merge sort, in the sense uh, uh, merge sort. So we've come to the end of like our divide part. Next we have to just merge them together. So that's what we have said here. And then uh, what we do is, so in when we call merge sort, we we call the m sort function iteratively, and then after that we merge it. So let's have a look at how the merge function works. So uh, they've asked us line y. So line y is where? Okay, it's in the beginning of our merge. So you can see they've given us the start, mid, and end. And you can see that so basically when you are doing this merge, since you divide it into two, uh, like sorry, so when you're merging, you will have two lists. So it's basically this I, J, and K. So from J to K, it's one list. From I to J, it's the other list. So I think that is what they're asking us to make. So I will give you the pointer to the first element of the first list, and J will give you the pointer to the first element of the second list. So in this, mid will tell you, mid will give us the last element of the first list. So then J will be mid plus 1. So again, I have to tell you, I mean, you have to go through the code and understand like whether it's plus 1 or just the value. So that's something you'll have to figure out. But other than that, so it's the same idea. So that's why I said, if you can watch that visualization video, there's quite a few different ones, like where they individually sort the algorithm, like do the sort on like do the sort visually, so you can see how it works, right? And then after that, the last question, which is line Z, is basically after we what we are doing is we are merging the two lists. So we first check, while like there are elements in both lists, we check which is the big element, sorry, which is the small element, and we append the small element to our temp list. Then so if I is smaller, we append from I. If j is smaller, we append from j. If one of the lists are done, so then we can just keep appending, like if one of the lists are done, we can just append from the remaining list. So you can see if I is less than mid, so because I is the element of the first list, if I comes here, we know that the list is done. Or if j comes to the end, we know that second list is done. So that's why we have these two while loops, and we have the same here with the and. And finally, so after that, after we are done with everything, what we do is we have to add everything from the temporary sorted list to the our actual list that we are sorting, which is data. So we've been given data with the so although we are merging, we may not be merging the whole list. We may be merging like maybe merging something like this part. So because of that, we have to first make a temp with the sorted values, and then we have to assign it to the final table. So that's what we are doing here, and that will give us the code in line in A. So basically in question 58 is A. So just have a look at these answers as well. If there's anything that's not clear, just let me know. Okay, so if there is no problems with that, then we'll move on to the last part, which is the architecture, the CPU sort of questions. So, which of the following CPU registers are accessed during execution of every instruction? So, every instruction, you know that the program counter increments for each instruction. So, because of that, it will be the program counter. GP, general purpose registers, every instruction mode need to access the registers. Similarly, the accumulator, like if you get like a NOP instruction, it will just increment the program counter. Similarly, with something like a jump. So because of that, these won't be accessed during those instructions. So program counter is the main part. Which of the following is not essential component? So you need a system bus, you need a ROM, CPU, output devices are necessary. A keyboard is not, like, I wouldn't say a keyboard is entirely necessary, because there are computers without keyboard. So, for example, even a phone is considered like a type of computer, but it does not have a keyboard, it has a touch screen. So, like that, there may be different input interfaces, and keyboard is one of them. So, keyboard is not an essential component. So next, which is the best term to identify computers that are used to control other equipment? So I had put none of the above, but I feel like IoT devices might be another suitable answer. So I'm also not really sure about this, but I think IoT might be a better answer than none of the above. So I think we can go with IoT there. Next is what is correct regarding according to von Neumann architecture. So when we take into play like these two architectures, so the we have von Neumann and Harvard architecture. So the way I remember, von Neumann is the architecture that most of our computers use. It's basically the CPU handles like memory access, uh, and also processing is done by the CPU. Harvard architecture is there are two different parts. So like memory access is done separately, and von Neumann memory access and processing are done separately by the so memory access, the CPU is not involved. So according to that, the correct answer will be C, where the processor is the only device in a computer that can process data. So that is correct about von Neumann architecture. So which of the following statements is correct about CPU instructions? So some instructions don't require an opcode. That is wrong, because we can determine what instruction it is with the opcode. Every instruction has an operand. That is also wrong. Some instructions do not have an operand. Like for example, which I gave you before, the NOP instruction. The opcode component is always fetched first. I think this is correct, because first you fetch the opcode, then only you fetch the operands. An instruction has only one operand. That's also wrong. Sometimes if you're adding two numbers, you will have two operands. And address is a part of the instruction also. That is not entirely correct. So I believe C is the correct answer for this. Which of the following affects the CPU's throughput? And this is easy. It is clock speed, right? 61 embedded computers. Yes. So I think Lasan had mentioned that the most suitable answer would be embedded computers. That is exactly the reason why I put none of the above, because I also believe that embedded computers is more correct to control other equipment. But then again, when you look at it, like IoT devices, I think are I believe IoT devices are like controlled with embedded computers. So I'm just checking on the internet. So I think there's a connection between the two. So yeah, as you mentioned, that is the reason I put None of the above. So uh, so if they've given that in the note, invisible computers. Uh, I mean, when you say hidden computers, I don't know. Like for me, it feels like a bit wrong. Like to say devices used to control other equipment are hidden computers. But yeah, if they've given you that in your note, then maybe you could take that. But uh, have they mentioned that embedded computers are known as invisible? Can you just give me the exact wording from your note, if possible? Invisible computers. Yeah. So yeah, if it's given in your note like that, you can take that. But yeah, some of these questions are very like tough to like say this is the exact answer. So yeah, I was not really sure about that question. But yeah, what you said is correct though. Like embedded computers would be, what would uh, control memories, control machinery. So I think, yeah, given your note, I think you all can use the term hidden computers. So I think that should be fine. So moving on to the next question: which of the following types of memory is always required to build a functional computer system? So here, I believe ROM is always necessary. So smaller computers will not need a read-write memory or RAM, but a read-only memory is, I would say, always essential. And cache is also not an essential part because cache is like an optimization. So cache helps us to access memory faster. So if you have like a very small computer, like a small chip, which has just a small amount of memory, like maybe a KB of memory or something like that, then a cache would actually not be very useful. But now our computers have like GBs of RAM, so then a cache is absolutely essential. So that's the difference. So that's why I put read only memory for that. So next 66, this is directly from your note. How do you write to memory? So first you put the memory location into address bus, then put the data into the data bus, and then you put the right control signal. That is that. Which of the subcycle is common to all the instructions? So obviously, yes, here also there was a bit of a confusion. So the fetch subcycle, operand subcycle, obviously you won't need for everything, but the fetch. Then after that, I was confused about whether this decode and execution also should be included. So uh, like uh, the reason I put fetch subcycle was I didn't put all of the above because some do not have an operand fetch subcycle. So I felt like maybe there are some instructions that do not need to decode. Like I feel like the NOP, you don't need to decode it because you just do nothing. So maybe it's something like that. So because of that, I put the answer as the fetch subcycle. So question number 68, it is a bit of a mathematical problem. So you just have to multiply the number of clock cycles by the clock speed and you will get the answer. So the answer is processor A. It's not that tough. Which of the following is likely to have the shortest instruction cycle? I've been talking about this. So it is the NOP. It's basically you fetch the instruction. When you see it's NOP, you just do nothing. You do nothing until the next clock cycle. So answer is a NOP. So next we have a flow chart. I mean, this is a easy question. So you just have to follow the flow chart and check the answer. So which of the following will be the output? So the answer is 4 for this, which I got was 4. So you just have to follow this. I believe this was, yeah, this was a prime. This is a prime number checking algorithm. So the answer is 4. So it will give you, I think it gives you the number of prime numbers, if you're not mistaken. So it will give you 3275. This is 4. So which of the following is correct about the running time of the algorithm? So for this, uh, uh, if you take t, the running time, is it proportional to uh, yeah, is it proportional to uh, is it proportional to n? Yeah, so that is the thing. So here we have, you can see we have two for loops. So there is a uh, see for, there's one, there's one for loop here and there's another outer for loop here. So whenever you have two for loops, usually it means that if you have two for loops, in a sense it's a nested for loop. So something like for something and a nested for loop, that means we are iterating over two loops, and if it's in terms of n, so that means we are iterating n times n times. So like n times n. So that means that many times. So because of that, then it will be proportional to n squared. So this will be such an instance. So I think the answer would be this and this. So because it will depend on the values of L as well. Because mainly because like if there are if it will depend on the number of values, it will depend on the magnitude of the values as well. So yeah, I believe so. I think this answer is actually D. Not sure why I put B here, but I think D would be more suitable. Uh, yeah, but why did I put D? I'm also not sure. Like, uh, yeah, I think the answer, correct answer should be D. So if you all get any uh, on the values, it's B. Yeah, since the outer loop runs n times and the inner loop depends on the values, it's B. Yeah, that's also a good point because so the outer loop will depend on, like let's take for it's something like this, no? For I in n, for j in by 2. So like when we usually take that the log notation, we would still take n squared, right? But uh, because still, like let's think if you have like values closer to n, you would iterate still n number of times. But yeah. Mm, so you can take proportional to n or proportional to n square. Yeah, so I feel like yeah, in that case it is closer to n because all the values uh, won't be the size of n. So yeah, we can take it as proportional to n. Then you can take it as b. That's fine. Uh, so question number question number 72. Let's go question number 72. The algorithm will output 0 if all values of L are even numbers. That is wrong because if it's 2, then it will output 1. So that's an error there. The algorithm will still work if J is less than X is changed. So that is correct. So this is what we've been taught as the prime number, the proper prime number algorithm. And similarly, the algorithm will take less time if this is changed to this. So that's also correct. So the answer was 2 and 3. So here they've given us a pseudocode, and yeah, so this was like a trick question because most of these would like would work, right? Had the same structure which would work, but the main reason that I selected none of the above was because the inner loop for all of these starts with j is equal to 3. So you may know that uh, if like mm, for example, uh, if if we are checking for divisible numbers, we have to check from 2. So the numbers divisible from 2, right? So mainly because of this was why I selected none of the above. But if yeah, at that point I think I selected this. If you all see any errors that you all think I missed, just let me know. But I think the answer for this was none of the above. So yeah, mainly because of this, just because of this. I don't know if it was a printing error on their part uh, or something, but just because of this, it will be none of the above. So suppose there is an algorithm to solve a problem. A student has just completed developing a program. Which of the following is not most likely to be correct? So P may have syntax errors, but it cannot have logic errors. That is wrong. So because even your code can have logic errors even though it doesn't have syntax errors. It can have logic errors but may not have syntax errors. So still again, that's also wrong. It cannot have any runtime errors if it does not have syntax errors or logic errors. Again, wrong. Cannot have any syntax errors, logic errors, runtime errors. Again, wrong. So I think the correct answer would be it's by reading it you can get that answer. Translation, compilation, and interpretation. The linking step in translation in compiled languages, object code is merged with precompiled libraries. That is correct. Program language translation uses both compilation and interpretation. That is also correct. And compiled languages tend to be more flexible with features like dynamic typing. That is wrong. Dynamic typing is a feature of interpreted languages. So dynamic typing is like you can define the types on runtime. So basically, you can have a variable like for Python. You can have variable I, and when you input I equals input. So here you don't have to define the type of the variable. It can be a string, it can be an integer, it can be anything. But in Java, you have to have languages like Java, compile languages, you have to define the type like this. So that is the advantage of dynamic typing. You can do what we do in Python. So that's that. The answer is 1 and 2. Finally, last few questions. Suppose there are two deterministic algorithms with the following. When a particular input will always follow fixed instructions. So the runtimes of algorithms X and Y will be the same. That is wrong. So uh, yeah. So uh, some of the because although it's the same algorithm, like same solving the same problem, you can go in different paths. So one would be wrong. Then the outputs of algorithm X and Y would be the same for uh, uh, any input. So what we are saying is two deterministic algorithms. The outputs of algorithm X and Y would be the same for any input. So that could be correct, given that uh, the answer is it's properly coded, then it would be the same for any input. So I think that is correct. And the length of code will be the same. No, that is wrong. Even the same algorithm, you can add an extra code. Just so the correct answer for this is B. So finally, we have the Fibonacci sequence. Here, they is given as the Fibonacci equation and the Fibonacci function, and how many additions are performed as a result of the call Fib6. So that you have to like slowly go into depth, and as you can see, you can maybe draw a table and find out how many. So the answer that I got was 12 for this. And how many times overall this Fib get called? It is 9. So that's what I got for that. And finally, which of the when computing Fn. Yeah, okay, so you guys have asked a few questions. I will answer them after I'm done with this, with the last few questions. So if you are just keep the questions coming, I will answer them all together in the at the end. So consider the following statements about computing Fn and the algorithm given below. The number of addition operations in the above recursive algorithm is linear in terms of n. No, that is wrong. The more deeper you go recursively, it will increase exponentially. Then we can develop an iterative algorithm for computing Fn. That is correct. You all may have done that as well. In an iterative algorithm for computing Fn, the number of addition operations will be linear. Still no. Wait. In an iterative algorithm, the number of addition operations will be linear. So if it's an iterative, we can we can keep saving the last two and keep going. So if it in that case, it can be linear. So I think that's also correct. Because we can like save, like let's think we save 0 0, and then we add the next one, which would be 1. Sorry, we save 1 1, and then we add the 2, which is 2, and then we add the 2, which is 3. So it will be linear. So because of that, 3 is also correct. So it will be 2 and 3. Finally, the last question, which is we are taking the integer of this, which is will be 3, and we are adding it with false. So an important point is when we add a number with false, what happens? You may think it's a type error, but actually in Python, false and true are given values which are 0 and 1. So false is 0, true is 1. So because of that, when you add here, you're just adding 3 to 0. So what you get is again another integer. So the type you get will be of class int. So that is the final answer. So yeah, let's answer your questions. Uh, in question 74, since the code is built according to the algorithm, can there be logical errors? Question 74. There is an algorithm to solve problem X. Student has just completed developing a program used on algorithm Y. Uh, can have so a student has just completed a program P. So it doesn't say it is a uh, it is a like they're not asking about the algorithm, they're asking about the program the student has built. So you may know that even if I were to code an algorithm, like let's take the merge sort, I would make many mistakes. So if I'm just because I know the algorithm, when I'm developing a program, there can be errors made on my end. So I think that is what I mentioned there was correct, because even though you know the correct algorithm, you can make logic errors, right? So I hope that answers that question. Then next, since the outer loop runs n times, oh no, wait. The inner loop depends on the values of the list. For some values, iterations is skipped. Can we still take t depends on n? Yes, that is a good question. So usually we would take for like I'm talking in terms of big O notation, which you all will learn when if you come to second semester in CSE. So that gives you the something like the upper bounds, like the worst case scenario, right? So uh, then usually you would take, like, you would give the worst case scenario, which is n squared. But for simplicity, I feel like you can take your answer and take it as proportional to n, which is what I also have taken at that point, mainly because it's something like the other reason is because it's not mm, yeah uh, mm, you can take it as proportional to n. Yeah, I think this was also one of the questions that I was confused with regards to. Uh, so, yeah, you can take it both ways, but I feel like the most probable answer would be n squared because it gives you like the worst case, regardless of what the values are. But uh, mm, yeah, that's a bit of a tough question actually. Like, if I'm going by like what I've learned so far, I would have to say n squared. But for you guys, I think even n would not be a problem. So unfortunately, I can't just say exactly, what is the correct answer without like knowing what the examiner thought. So yeah, let's move on to the next. I hope that answered your question. So I think if you all get this question, uh, I would say if I was to do it again, as you guys, I would probably put n squared. Yeah, I think n squared is the more suitable answer. So mm, yeah, next question. I will just go through. Just give me a few minutes. I'll go through this again and check. There's a alternative explanation for this. Mm, put list n. Okay. I think. mm, mm, Okay, so I'll just, while I'm checking that, I will move on to the next question. Can any input mean all the possible inputs? Uh, can any input? Yeah, I mean, it when they say any input, it usually means all possible inputs. Yeah, that I think. Yeah, if you can just give me the context of what question you're asking, just let me know. Why is it required? uh, a ROM and not a read write. Uh, so can't we consider a hard disk as a read write and instead use it as a ROM? Yes, true. You can use it like that, but mm, like let's say, how would I give an example? Mm, like if you take a simple computer which doesn't need to right, I'll double check this as well. Mm, right. So with regards to the first question regarding the uh, prime number calculator, so when we are talking about this algorithm, since we are going from uh, like since we don't have that since we don't stop, as mentioned, like now here we have said that we know that we can stop at somewhere here, here we know, we can say then in that case it is not proportional to n squared. But since we are going all the way till that number, then it's better to say it's proportional to n squared. Regarding the read-only memory, and uh, regarding this that question, mm, so the reason I put read-only memory is because read-only memory is usually essential. Like it has the like when you're building a functional, like when you have a basic computer system for anything to start up, you will need a read-only memory. So the difference, read-only memories, it is not volatile, so it won't change when you show. When you're booting up a computer, all the data that is saved regarding booting up is in the ROM. So that is why it is essential to have a read-only memory, because if you don't have one, you will boot your system without any data, without, and I don't think you can boot your system up even. So because of that, I think that's why I put read-only memory. So uh, because a read-write memory, those as you may know, these read-write memory, those are like RAM. These are volatile. So most of the time, RAM will erase its data once you shut down your computer. So that's the problem with these volatile types of memories. So you can't have your like your BIOS. You can't have those on your RAM. Mm, so that's which is why I selected read-only memory. But if you think that a read-write memory is also essential, then you'll have to select all of the above. Uh, because read-only memory is essential. If you want to consider read-write memory, then I believe that you'll have to select like cache as well, because yeah, read-write memory. Mm. So yeah, you can. I mean, another answer that you could give is uh, all of the above, because they've said a functional computer system, so they could be expecting to mean something like not a very basic computer. So now even like you can build a like chip with only a ROM, but that will have like almost little to no functionality. You can have like some specific functions that it can do, and then it will just shut down. So maybe when you say a functional computer system, then cache and read write memory also could be correct. So I think maybe you can go with that answer actually, since they have mainly because they've said functional computer system. So maybe they mean like when they say functional, they mean like you can do some like more advanced capabilities. So yeah, I think D would be a more suitable answer. So I think that's all good. So good. Thanks for asking like the questions, because there are some small areas that I also may have missed. So it's good that you all could figure those out. So yeah, if you all have any other questions, you can ask. Otherwise, we can end the session. So yeah, we'll just give you like yeah.
A big thank you, Ovindu, for taking time to conduct this session amidst exams. The effort you put into making the session valuables means so much to us.
All right. Thanks, man. I'm glad to help. Good luck for your exams as well. I'm sure that you guys will do a good job. May so because of that, keep just like don't panic during your exam. Just keep doing. I mean, you all have quite a few more, so you all can do those well. So good luck, guys. Okay. I think there's one more question still.